have the pressure vessel, rods, moderator, and shielding. What are the main components? The various components of the nuclear reactor will be having the nuclear reactor core. Reactor core, the main purpose of the reactor core is that the entire course of the nuclear reaction will be taking place inside the core, and followed by the moderator. The function of the moderator is to stabilize the chain reaction that is taking place in the nuclear reactor. The main function is to stabilize the nuclear reaction rate inside the reactor, followed by the control rods. So this control rods will, the basic function of the control rod is to initiate or to stop the course of a nuclear reaction in the power, inside the nuclear power plant. And reflector is to simply reflect back the neutrons in that particular process, right? So then the neutrons, the electrons, the neutrons should not be escaped from that particular shielding. So that has to be ensured with the help of the reflector. So we have to choose the reflector in such a way that no neutron should be escaped from the inner core of the power plant. And we have the cooling system to reduce the internal core temperature of the power plant. And we have the reactor vessel to withstand the entire pressure and temperature during the course of the reaction. And we have the biological shielding. Basically, the main safety protocol that has to be followed is that if some amount of radiation has been taken out from the nuclear power plant or escaped from the nuclear power plant, it will cause the hazardous effect to the people. So we have to have the proper biological shielding in the nuclear power plant. So this is a reactor core. As you can see here, the reactor core is the outermost boundary is the reactor vessel, and the inner part consists of the center core, and the core which consists of the core is nothing but it is a summing up of the control rods along with the reflector, and we have the moderator and fuel rods. So this four integral components will be cumulatively taken as the nuclear reactor core. So whenever we talk about the core is the combination of reflector, moderator, fuel rods, and control rods. The fuel elements are made up of the plated or rods of uranium metal. The plates are usually cladded with the thin sheet of stainless steel, zirconium, or aluminum to provide the corrosion resistance. As we have already discussed, the element should have the proper corrosion resistance, and the machinability rate of that particular component should be much higher. The fuel is shaped and located in such a way that the heat produced with the reactor is in the uniform way. So as you can see here, it consists of the nuclear fuel. The the reactor core consists of the nuclear fuel, the neutron moderator, and the space for the coolant. The nuclear fuel is an element or an isotope whose nucleus undergoes nuclear fission by the nuclear bombardment, and it's produced a fissionable chain reaction. So adequate arrangement has to be made for the fuel supply as well as charging or discharging and the storing of the fuel. So what is the purpose of the moderator? The process of the moderator is to slow down the nuclear reaction that is taking place in the nuclear power plant. So the method of reducing the speed of the reaction is done with only with the help of absorbing the neutrons from the particular thing. So whenever you absorb certain amount of neutrons, obviously the speed of the process that is taking place inside the reactor will be reduced. So this neutron plays a vital role in order to kickstart the process or to slow down the process or to stop the process. So for all this process to happen, we have to either supply the free neutrons into the reactor or to absorb the neutrons from the reactor. So the moderator is a material which is used to slow down the neutrons from the high velocity without capturing them. So what is the function of the moderator? So the moderator will moderate the process that is happening in the nuclear reactor. Moderator function is to slow down the process of the reaction. As we have discussed earlier, the moderator will slow down the process of the reaction. So what are the basic moderators that can be used is that we can use either heavy water or we can use the normal water, beryllium, graphite, helium gas, right? The last one is the helium gas. So the helium gas are the commonly used moderators. So based upon the kind of reactors we are going to choose, we have to select the suitable moderator for the particular nuclear reactor. What are the moderator properties? It should have high thermal conductivity, high slowing down power, low parasite captures, it should be lighter in weight, and it should be highly stable. The function of the control rod is to shut down or to kickstart the process of the reaction in the nuclear reactor. The cooling system has to carry out the particular amount of heat that is produced inside the reactor. The cooling system should have low melting point, low boiling point, and low viscosity. So biological shielding, as we have already discussed, it should be able to absorb alpha, beta, and gamma type kind of radiation that has been effectively taken from the nuclear reactor, and the shielding material should be of the uniform density, and it should not be decomposed by radiation. It should be fire resistant as well. So basic kind of reactors that we can see is the boiling water reactor and the pressurized water reactor. In the boiling water reactor, you can see the reactor core followed by the steam turbine, condenser, and heat pump. So this boiling water reactor will be using the normal water as a moderator, as well as it can be used for the purpose to control the chain of process of the nuclear reaction. And in the case of the PWR, that is pressurized water reactor, we have the pressurizer that has been used in the pot. As you can see here, we have a additional component, the pressure equalizer. So this pressure equalizer will ensure that the reactor is working based in the higher pressure value. So whenever the pressure is being increased, it has to make sure that the coolant, the reactor is running at a particular required pressure. So we have a critical pressure value in which the reactor should be operating for the entire course of the operation. It should be operating in that particular pressure value in order to maintain the production of the power as well as for the other output characteristics, other improvised output characteristics. So that's all for today's presentation. Thank you, and we can see this in the other classes to come. Thank you.